Welcome to Omegamon for Db2 Application Trace Facility. In this video, I will provide an overview of the Application Trace Facility, which is one of the key components of Omegamon for Db2 Classic Monitor. There are two types of monitoring in the Db2 subsystem. The first monitors snapshot data, which is also referred to as real-time monitoring. This is used to review current workload executing within a subsystem, as well as real-time alerts that are user-defined. The second is called event trace data, and this is based upon starting an event-based trace. This facility supports the selective tracing of threads related to Db2 application and allows the user to drill down and capture activities such as CPU, class 1 and 2 and 3 times, SQL and sort activity, buffer pool, and page set information. Today, we will focus on event trace data. To initiate a Db2 application trace, we first have to select option A from the classic main menu. From the application trace facility menu, we have several options. Option A allows us to specify the trace. Traces can be either written in memory or they can be written to a vSAM data set. Options B and C deal with in-memory tracing. Option D deals with dataset tracing, where you can select the vSAM dataset, view the dataset, or stop the view. Option G is how we create the vSAM dataset. That's what we're going to do next. From this panel, we're going to enter the dataset name, and we're going to assign a size in megabytes for the dataset. We're next going to hit enter, and we can see the definition of the cluster and the data component for the linear dataset. From there, select PF3, which will bring us back to the application trace facility menu. Next, select S next to specify trace. From this panel, we can trace an individual plan or all plans, threads executing in a Db2 subsystem. It is strongly recommended that you qualify your trace requests as much as possible to limit trace overhead incurred in both the Db2 subsystem and Omegamon. To qualify a trace request, enter the required information for only one of the connection types, TSO, batch, CICS, or IMS. The DSN is the name of the vSAM dataset that we just created. If you desire to have the results of your trace reside in memory, then you leave the dataset name blank. In this example, I've decided to put an application trace on a batch job named dbquery1. dbquery1 is running the plan name of DSN-TEP2 under my auth ID. Once we hit enter, we'll have another screen called Trace Level Details. Here you can specifically select attributes of this trace that you want to collect. Next is the trace duration and scheduling. There's a memory size from 0.1 to 0.4 meg, which is used for in-memory tracing, which we're not going to be using this time. There's a duration for the trace, and we'll set it for 5 minutes. The next thing we can do is a deferred start time and a deferred stop time. If you want to put a trace out there with a start time and an end time, this is where you can specify that. The other options you have is, do you want this trace data written out to SMF, yes or no, or do you want it written out to GTF as well? Once we've entered all our trace information, we'll get a press enter to start the trace or 3 to terminate the trace. By pressing enter, you'll see the data trace request initiated message on the bottom. If we're then able to connect to a Db2 subsystem and do a display trace command, we would see that performance 32 trace has been initiated from that Omegamon application trace request. Hopping back to Omegamon, once we hit PF key 3 from the data trace request initiated message, it will then bring us back to the application trace facility main menu. We're going to select H for queue traces. From this panel, we can then put our cursor on the status of the trace that we just started and press PF11. This will open up the queued application trace details. As you can see on this screen, the trace status is active. We have a start time, we have an end time, we have basically a trace limit time. We have the number of records that have been captured, and it associates the plan, auth ID, and job name that are associated with this trace. We will next select B to view the data set. This will bring up the application thread summary screen. Here we have the dataset, the VSAM dataset we use for the trace, the start time, end time, the plan auth, and correlation ID associated with this trace. You can see the in Db2 time, the commits, and the aborts as well. I will now show you a menu to navigate the trace records. From the thread summary, we can hit PF11 and get a unit of work summary, and press PF11 to zoom into the program summary. From the program summary, we can zoom to the program detail, or select option B for the SQL index, option C for SQL detail, D for lock detail, or E for event detail. Using that chart, starting with the application thread summary, I was able to drill down to the unit of work summary. From there, I was able to drill down to the program summary and also the program detail levels. Application traces can also be initiated via the thread activity detail screen by selecting option S. This concludes the